nuclear energy, nuclear medicine and radioisotope production, mining exploration and exploitation, nuclear application and agricultural activity, cultivation sterilization, nanotechnology, National Atomic Energy Commission of Argentina. The National Atomic Energy Commission of Argentina is developing its first nuclear power plant totally designed in Argentina, the prototype CAREM25. The facility will be located a few kilometers from Lima, province of Buenos Aires, next to Atucha 1 and 2 nuclear power plants, and it will generate in the order of 25 megawatts. The nuclear industry has the highest quality and safety standards worldwide. In accordance with this, the National Atomic Energy Commission of Argentina assumes the construction of CAREM, respecting the highest safety requirements such as the anti-seismic structure. The CAREM main building will have a surface of 20,000 square meters and will be built with the most modern materials. The control room is one of the most important areas of the plant. It will have cutting-edge technology. All the functions will be monitored, including pressure and temperature inside the reactor, core power, and the state of fuel. CAREM plant operators will carry out control functions that double reactor safety measures, since practically all its functions are automatic. The pressure vessel stands at the heart of the building, 11 meters high by 3 meters diameter. It's located inside a wide concrete and steel containment, which guarantees that the entire process will be kept confined to this area, reducing the possibility of leakage to the environment. The primary circuit of a nuclear power plant is the system of water circulation that cools the core. The secondary circuit, another independent water circuit, generates the steam that will move the turbine. CAREM integrates the primary and part of the secondary circuits to the pressure vessel, reducing the amount of pipelines and consequently the probability of a loss of coolant accident. LOCA. This integration inside the vessel is one of the distinctive features of CAREM, ensuring that the water that acts as a core coolant will never escape from the pressure vessel, increasing the safety level. CAREM operation takes into account fuel element replacement every 18 months. The fuels will be withdrawn from the pressure vessel using special tools, and then will be placed into a dedicated pool. Once the fuel is sufficiently cold and stable after several years in this pool, it will then be sent to a safe and final disposal. Nuclear fission is a process by which certain minerals such as uranium are fragmented, releasing a great amount of energy. By being fragmented, each uranium atom emits neutrons that at the same time impact on other atoms. These in turn are split and release more neutrons, continuing in this way into what is known as a chain reaction. The chain reaction is controlled by means of the insertion and withdrawal of the control rods. These are made of a material that absorbs the released neutrons traveling within the vessel. Some of these rods remain suspended above the core, and if necessary, fall by the pull of gravity. The rods are thereby totally inserted into the fuel elements and shut down the reactor within 2 seconds. Due to the heat produced by the nuclear fission process, when the water passes through the core, it is heated and moves upwards into the pressure vessel until it reaches the upper sector. It then flows downwards along the walls, leaving part of that heat in the integrated steam generators. It returns to the bottom, now cooler than before, where it will be warmed once again, and the process is then repeated. This is called natural circulation, and through this process, the water moves due to the changes in temperature. Therefore, the use of pumps or other devices is not required. This fact simplifies the design and makes the system safer. By being warmed through contact with the water of the primary circuit, the water of the secondary circuit turns into steam and generates the necessary strength to move the turbine. Then it is cooled down with a tertiary circuit that is filled with water obtained from a river or lake. The steam is cooled once it has passed through the turbine, turning into water and repeating the process once again. Electrical generation is similar to that which is obtained through conventional plants such as hydraulic or coal. The turbine rotation causes a generator to move. It is this generator that produces the electrical energy that is destined to supply our homes. The main difference with other plants is the way in which the steam is generated. In all nuclear plants, this is achieved by heating water through the controlled fission reaction of the uranium. CAREM has passive systems as its main safety features. That is to say, they act with no external power supply, and they have the capability of self-operation without human intervention for more than 36 hours. CAREM also has active systems that are redundantly fitted, with defense in depth that prevents the dispersion of radioactive material thanks to 3 barriers: the metallic structure of each fuel element, the pressure vessel walls, and the concrete and steel containment that surrounds it. With more than 60 years of history, thanks to the efforts and dedication of scientists, engineers, technicians, and specialists, combined with the participation of its associated firms, the National Atomic Energy Commission of Argentina has designed, built, and operated more than 10 research reactors. It has also been involved in the construction, operation, and maintenance of Embalse and Atucha 1 and 2 nuclear power plants. This experience enables the National Atomic Energy Commission of Argentina to build the nuclear plant of the future. CAREM.